part of this Presidio.codes series, we like to look at how to use code to implement daily activities that you do. So one of the things I'm doing is looking at home security, home controls over my heating, cooling, the amount of water in my yard, these types of things, and thought it'd be nice to graph them. So playing around on the weekend, invented this, but this could be used for various numbers of things. As we set up the code for this, you could simply use, say, NetMiko to pull a set of information off of a switch and graph that. Again, in the second part of this series, we'll be looking at pulling SNMP variables using Telegraph and feeding that into the InfluxDB and into Grafana to actually chart that. So as we go through our journey here, let's see what we're trying to do first. So as you saw, we're trying to build a graphical output database of a data set and kind of keep an eye on it. We can color code things and we can set alert levels. So we'll go through all of that. Also showed you the time slice of this, so you can keep an eye on when things are happening and drill into that sort of data as well. So what does our system actually look like? Well, what we've done is we've created a pseudo set of IoT devices here so that we can run this in the office and capture it. I've written a program, a pseudo device, that actually generates this code and publishes that using the MQTT library in Python. So the MQTT library will publish out in what we call topics to a message broker. That message broker is called Mosquitto. That's just a MQTT message broker that does the subscriptions, takes care of the actual authentication, these types of things. And then written another program that you see over here underneath my little robot there, a program that subscribes to that MQTT data and then does some quick data manipulation and pushes it to an Influx database. So then I've actually co-located these where I have the Influx database server, which is just a time-based server and deals specifically with measurements. So it's something that we're actually doing here and fit really well. And then that is tied into the Grafana graphing server. So we watch the output of that. That's actually just creating web pages. So in a web browser, it'll automatically do the updates. And we do that over port 3000, which is the serving port for the Grafana graphing web server. So let's look into these individual components a little bit closer. So MQTT, it was originally an IBM oil field messaging protocol that was written to bring back lightweight messages from the oil fields over satellite communications. So one, it was very delay capable. Two, it was not always transmitted, so it has some QoS parameters built in. Three, just very lightweight, so you weren't burning a lot of satellite bandwidth. And the way it works is they use streams, which are called topics. And each topic has two different parts. So one is the publish part, so I'm going to send data out on a topic. The other is subscribe, where I'm going to listen to that topic and any messages that come out. So to do this, everybody points to the broker. So you can have multiple publishers publishing on a topic to the broker, multiple subscribers listening to those topics. So for example, you can have a logging server that listens to it and just logs everything. You can have various, say, microservices that actually do something with the data. You could have thousands of individual small, oil field sensors out there publishing their data into the broker. And the broker can handle all of this. It can handle multiple topics. It can handle user logons and the admin. It can handle authentication components, all of these different things in the broker itself. So when you think about a topic, it's really just a tree structure. So you'll see I called mine test is my main head of the tree. And then I have one for power, one for temperature, one for bandwidth. And then I have each individual sensor underneath there that's putting out the data. So I can have a topic called test, power, sensor 1, which is the current power level of sensor 1, and it's just going to publish a measurement on that topic. Again, don't forget, though, that there are actually 2 topics to every topic stream. There's the publish, which is push to the broker, and there's the subscribe, which is basically pull from the broker. So when you think about a topic, it's actually 2 streams with 1 name. Now, of course, you can see right below there's test temperature sensor 3, so that's just the temperature reading for sensor 3 is going to be a topic. There are some shorthands that we're going to use. Test power / pound is all the 5 sensors we're going to use in the power readings, or just test pound is all of the topics in the tree. So I can subscribe to all of them, but still read the actual topic itself and put the data in the right place, right? So you have this tree-based structure. You have a lightweight protocol messaging system. It's nowhere near as complex as, say, HTTP is. An easy way to publish and subscribe, and an easy way to build these topics, which can be hierarchically looked at. So MQTT gives you a lot of capability in a very, very lightweight package. I'm using Python. It just happens to be the language I'm currently most proficient in. But MQTT has Arduino libraries for their C version, Java if you want. It's got lots of different implementations for lots of different programming languages. So it's something that's quite often used to send quick, lightweight messages and make sure they're read once. You can do them in sort of a UDP protocol. You can do them in read once, in which it's simply deleted from the broker after it's been read, or read at least once, in which it's kind of like a TCP acknowledgement. Packet has to come back, and it won't erase it until it's been acknowledged to have been read at least once from each of the subscribers. So there is some QoS built in. We're not going to get into that very much, but I recommend you learn how to do the QoS components of it if you need that for your messaging. So the Mosquitto Broker, what is that? That's just a server daemon that sits there, and it basically is both subscribed to all published messages and publishes all subscriber messages and keeps track of all that. It also handles the security, encryption, message storage, these types of things. So it's just a daemon that sits there and works with the MQTT protocol and handles the translation between publishers and subscribers. It handles a one-to-many, so many people can publish on a topic, many people can subscribe to a topic. It handles all the one-to-many connections as well. Okay, so once we've got that data, we're going to put it into InfluxDB. InfluxDB is a lightweight, again, database. So a lot of these IoT things, you'll keep hearing me say the word lightweight. What it does is it manages a time series database really well. So the database is really talking about putting out a measurement. So for example, voltage should be around 120, right? You can set that as either an integer or a floating point. It's going to have a source so that it knows what device that measurement is associated with, and everything that comes in gets a timestamp. You can either feed it a timestamp, or it will automatically run its own timestamps on everything. And that's one of the reasons we call this a time series database, because everything is a measurement. Of that measurement, you will have a source and an actual value of the measurement. Of course, you can see that that leads perfectly to these visualization that we've already seen here using the Grafana, the front end to it. The other thing is they've written it using a SQL-like language commands. They're very SQL. They don't do a lot of the advanced things SQL can do. But you'll see select star from the measurement name with source equals whatever your sources. So you can set these things. If you're familiar with reading a little bit of SQL, you only need about 10 commands, and pretty much you'll know what's going on in the InfluxDB Datastore. Just to show that off, I can say show databases. Here I have one called IoT. So the IoT database, I'm going to show my measurement. I'm going to use my IoT database. So that says any command I say from now on will just use that database. I say show me the measurements. Well, I have 3 measurements in there: bandwidth, temperature, and voltage. So those are the 3 things you saw graphed earlier. So now I can throw my SQL-like select statement in there that says select everything from the measurement voltage where time is now minus 40 minutes. Why is that? Because I had shut my data generation system off, and I had to reach back 40 minutes, but I didn't want to reach back 45 minutes or you would have had a screen full of stuff. So I just wanted to capture some stuff. So what you see there is the name of the measurement is voltage. The time there, that's the timestamp associated with everything. Then I've got the sensor name, 1, 2, 3, 4, and 5, and the values. So these are the voltage values I took off those 5 sensors. And as you can see, that's a record in my InfluxDB Datastore that's real easy then to turn into a Grafana visualization. The other nice thing about Grafana is it speaks this InfluxDB Datastore select statement. So you're actually going to build that type of statement and say, I want all my sensors from voltage, and make them look like this, and check them every so many seconds, and you build that select statement, and then it actually uses that to produce the graphs. So now you can see kind of how we glue this all together. So what is Grafana? Grafana is probably the second most used visualizer after Kibana, which is part of the ELK stack. We're doing something similar to the ELK stack, but the ELK stack is very powerful. We're using something much more lightweight here for our IoT, or even later for our SNMP queries, and that's where we're going to use Grafana. It's specifically made to do a time series database much more easily than, say, Kibana, which can do log scraping and a bunch of those other types of things, which are a little bit more complex. So it's an open source data visualizer. It is a web server that has an engine behind it that actually produces your visualizations, be they histograms, pie charts, bar charts, color-coded words. There are a lot of different things you can do with it. Once you start playing with it, the sky's the limit. The other nice thing about it is you can build in your own mathematical calculations. So if you need to say something can be no more than 105%, or you want to turn it from green to yellow, or 110%, you want to turn it red, you just put your mathematical calculations in, and it understands how to change colors, how to change information on the screen. And then once you've set up those types of alerts, it also does outbound messaging. So it's really good about that as well. Another cool thing about Grafana is people will share their dashboards. So if there's something you're trying to do, you can't figure it out, you can probably find out there somewhere a Grafana dashboard that's already been built, and import it and then just start tweaking it from there. The MQTT library itself is a Python library. What we do there is we simply import it. It's called the PAHO MQTT client library. It's actually by Eclipse, the same people that make the Eclipse IDE. You're simply going to set the broker address. So this is our Mosquitto server. That's the address of our Mosquitto server. You create an instance of a class. So this one's MQTT client class. You give it a unique name because, as somebody here found out, if you try to give them all the same name and you copy and paste them, it tends to knock each other offline, so you don't want to do that. So that's why I've called it unique name, to remind you to put a different name in each server that you're going to build here. So from there we have our instance called client. We're going to do a client connect to the broker. That establishes the connection. Here's where we put in username, password, those types of things. This is just a lab system, so I haven't put any authentication systems in there. And then to publish, you simply say client publish, what channel you want to put it in. That's the topic that you're going to put it on and the message string you're going to pass it. It's pretty much that simple. To subscribe, you actually just go in and you subscribe to a topic. So this says, subscribe me to everything in the test topic tree. The InfluxDB Python library, so we're going to use this to write into the InfluxDB database, right? So InfluxDB client is the class we're going to import. As you can see there, there's a little bit of a typo there. I'm going to go ahead and fix that while we're talking. You're going to say, give me an instance of InfluxDB client. I'm going to call that Influx client. The server we're going to connect to, that's where the database server is. 8086 is the port on that server, and the database we're going to use is called IoT, as we saw earlier. That's all you need to do. You now have a connection from your Python program to the client. The way we're going to deal with this is through some callback messaging. So what you see is we're going to receive a message in from that we've subscribed to. We're going to actually decode that message as a UTF-8. We're going to find the current time. We're going to produce a JSON of the measurement, which is voltage, the tags, the sensor, which is the sensor name we've read from our message, the current time, which we just created here out of the system time, and then the actual value. We're going to pass it, and then we simply write this JSON body into our database. So that's all it takes to take our data in off our message queue. When we receive a message, write it out to our database. So we'll go over that code a little bit more in detail later on, but just kind of wanted to show you what the library actually consists of. So finally here, once you connect the Grafana to the InfluxDB, when you're configuring a data source, you simply find InfluxDB. You can see there's also CloudWatch, Elasticsearch, MySQL, Prometheus, Stackdriver, Postgres, Microsoft SQL. There's a lot of stuff out there. InfluxDB happens to be one that's real easy to set up. Once you've set that as your data source, you're simply going to give it a name, point to where it is, see what kind of authentication you want, and tell it the database name, and then you've made a connection from your Grafana to your dashboard to your InfluxDB. From there, you simply build your Grafana dashboards, which we'll go through and actually build one of these in a later segment. So those are all the tools we're using and the structure of what we're doing. So in the next session here, let's talk about how we're going to go about installing these various components.